I glanced out of the window today. What season is it? What is it like? It's the sun shining on the rain and the rain falling on the sunshine. Spring suddenly entered our lives like a playful child who bursts into the room and has flowers smelling, blooming, so fresh and happy. William Shakespeare described this month of April in his own special way. April hath put a spirit of youth in everything. The season is great and there's a wonderful change, along with the turning verses in our telltales too. Let's set the ball rolling today with secondary active transport. Welcome all to Is Pharmacology Difficult podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find, and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Secondary active transport. In this particular type, the driving force is due to a single ion or solute, and it actually supports the transport of another ion or solute. The another one is generally a sodium ion. Now what happens actually is there is a one more set of SLC. Yes, I'm talking about the capital SLC transporter, which is expanded as a solute-linked carrier transporter. This capital SLC transporter, it affects the whole process. There occurs a downhill movement of the other ion, which I'm talking about is, yes, the sodium one. And on the basis of the direction of the two ions or the solutes, there can be two types of transports. The first one, when both the ions or the solutes, they move in the same direction, then this particular type is known as symport or co-transport. Yes, that really makes a lot of sense. But second condition, if the motion is in the opposite direction, then this whole transport type is referred to as the exchange transport or antipode mechanism or counter transport. There is no direct ATP involvement in this whole process. Rather, energy from the ATP hydrolysis is used to maintain the high differential electrochemical gradient. Are you getting this whole thing? What I'm saying is that directly there is no ATP involvement. There is nothing to do with ATP in this whole process, but yes, whatever energy is derived from the ATP hydrolysis, that energy is indirectly used. What is the use of this energy? To maintain the electrochemical differential gradient. Now this is an active transport, or it can be a facilitated diffusion. Anyone can work here. And yes, both of them or any one of them may lead to the uptake and the efflux of the drug substances. I hope you're getting the crux of this whole thing what I'm talking. It's a little technical thing, a little complicated, but nothing very tough. So I hope you understood the whole ATP involvement, whether it's direct or indirect. Yes, it is indirect. And the other one thing I'm talking about is the whole process can be in the form of an active transport, it can be in the form of facilitated diffusion, and both are serving the function of uptake and efflux of the drug substances. Now that was so easy. Now some important secondary active transporters are, first, capital OATP. it stands for organic anion transporting polypeptide. And second, capital OCT. It stands for organic cation transporter. Now there are specific transporters for norepinephrine, dopamine, serotonin, and accordingly they are named as capital NET, capital DAT, and capital SERT respectively. And I'm sure you might be knowing about the capital SGLT1 and the capital SGLT2. These are sodium glucose transporters which are found in intestine and kidney, and they are also secondary active transporters. Okay, now there's so many and wonderful examples that I've given, so you can learn all of them, you can learn few of them, but please learn them. Now let's bend our waves of speech towards the membrane transporters. These membrane transporters, they are protein molecules. What is their function? Their function is to get involved in the efflux or the influx of the drug from the cell. And broadly dividing, we have two superfamilies of drug transporters. Yeah, there are two superfamilies. Now, what are the great names of these superfamilies? The first one is the capital ABC superfamily. Yes, you got me right. Capital ABC stands for ADP binding cassette. Now, this is what I already told you. It is involved in the primary active transport, not in the secondary one. And as far as the research is concerned, about 7 subclasses are known till date. The most reputed one, you guessed it right, it is the P-glycoprotein, or it is also known as the capital MDR1. Okay, let me share a teet here with all of you. The basic secret behind calling the P-glycoprotein as the capital MDR1 is why? Because it is derived from MDR, that is multi-drug resistant protein, via the process of single mutation. So because there occurred only one mutation, the P-glycoprotein, what we got, is also known as capital MDR1. See, that makes a lot of sense, right? Now, why we are highlighting our talks with these transporters? Because capital MDR1, its inhibitors, its inducers, they are game changers in drug interactions. Did you get that? So you know why I'm talking about these superfamilies, their examples, and especially I'm highlighting one particular example, what wonderful function, what important thing is related to it, and how it serves as a game changer. Okay, next to comment upon, the next superfamily I want to talk about is the capital SLC. That is a solute linked carrier transporter. Now this, we did it today. It is involved in the secondary active transport. Till date, via the research, around 43 families are quite well known, and some good to know names in this particular field or context, they are capital SERT, yes, that is for serotonin, capital DAT for dopamine, capital NET for norepinephrine, etc. And then we have capital GLUT, glut transports too. Now, some quick facts. Let's get to know about the carrier-mediated transport. First one, whether the transport is facilitated diffusion or it's an active transport, both are capacity limited. Now, what does that mean? They can achieve the saturation line. Got it? And what kind of kinetics you expect them to follow? They follow something which we call as Michaelis-Menten kinetics. I'm going to discuss this in detail in the upcoming episodes, well, quite very soon. I don't know when because I don't know the length, I cannot predict, but surely in upcoming episodes. Now, next quick fact about these carrier-mediated transport is that genetic polymorphism. You understand about genetic polymorphism? It is related to the genes changes. Now, when the gene changes, when polymorphism occurs, it alters the transporters too. And what happens? It finally affects the drug mechanism. I'm talking about the pharmacokinetics of the drugs. And lastly, one good advantage is, there is one advantage what we should know. There are specific transporters in some kind of special cells in our body. What is their function? What is their need to promote the specific drug distribution? Isn't that wonderful? With this wonderful quick fact, I want to comment that today is a wonderful day too. It's the apt moment to let out a grand Thanksgiving in the universe for the BELLISSMIA GIORNATA. That's an Italian phrase for a beautiful day. So the ideal way to end today's colloquy is this beautiful remark, and a new phrase, Italian one, is BELLISSMIA GIORNATA. For all the updates and latest episodes of my podcast, please visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about the medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name, is Pharmacology Difficult. If you are listening for the first time, do follow me here, whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.